Yeah, yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not?
Oh, your skin is visible for me.
Yeah, fine, thank you. So what is big data? Why Hadoop and Spark? Drawbacks with the current databases. Drawback with the current databases. Advantages. Hadoop and Spark. Scope and job market. Hadoop and PySpark. Yes. So what is big data? Why is Hadoop? Why Hadoop and PySpark? Drawbacks with the current databases. Advantages of Hadoop and PySpark. Yes. Scope and job market of Hadoop and PySpark. Yes. So myself, I am Vijay. Like I hold 20 plus years of experience, which includes in different technologies, right? Yes. So this is what I'll be discussing, right? So here in this course, you'll be learning about four things here: big data, that is Hadoop, PySpark, Linux, Python. Yeah. Starting with the big data. Starting with big data. One second. Big data, the name itself saying like huge volumes of data. Currently, how the data is getting stored. The data storage units, right? You should have seen KBs of data. You should have seen MBs of data or GBs or terabytes of data. But today, data is getting generated in petabytes. Data is generated in petabytes, right? One petabyte equal to 1024. One petabyte equal to 1024 TBS. Means, yeah, 1 petabyte equal to 1024 TBs. Already 1 TB is a large storage unit, but petabyte equal to 1024 TBs. So examples of petabytes of data generation. Pet examples of petabytes of data generations, right? We take example of any banking sector like SBI, any banking sector, right? Like SBI or HDFC. Within the city, you see hundreds of branches of SBI. Within the entire state, you see thousands of branches. Within the entire country, lakhs of branches for SBI. Again, within each branch, millions and trillions of customers, right? Again, they are making multiple transactions per hour, per day, per week, per month, year, right? So huge data is getting generated. Forget about this banking sector, but you are aware about social media like Facebook. Facebook has got users not only within the country, entire world. It has got millions and trillions of users throughout the world. What is the data generated by Facebook in a minute? How many posts and videos are getting circulated in a minute? Huge data, right? So Facebook generating data in petabytes. Not only Facebook, today if we talk about different applications, then generating data in petabytes. Facebook, if I take 1 minute transaction, 1 minute transaction, if I take 1 minute transaction, what is the data generated by Facebook? What is the data generated by Twitter tweets? What is the data generated by Google queries? Today, everyone are querying in the Google, right? What is the data generated? Data generated by Google. And YouTube videos upload. What should be the storage capacity to store all the videos, right? Email or Gmail messages. Storing millions and trillions of users. This now is talking about bank transactions, telecom transactions, bank transactions, telecom transactions. We talk about the Flipkart and Amazon transactions, e-commerce transactions. Everywhere we see like huge data is getting generated in petabytes. Currently, we have got databases. Right? Databases like Oracle, MySQL, DB2, SQL Server. Currently, we have got databases like Oracle, MySQL, DB2, SQL Server, right? Yes, for OLTP operations. Yes, currently we have got databases. Currently, we have got, okay, for OLTP operate, and we have got some specialized databases. We have got some specialized databases. We have got some specialized databases which are used for data warehouse operations, right? Like Teradata, Netija, Vertica. Yes, specialized databases like Teradata, Netija, Vertica. All these they are used for OLAP operations. They are used for online analytical processing. Either these databases or specialized databases, they can handle data up to some extent, but beyond that, it cannot handle, right? Means if it is data in petabytes. So, so as a solution to this storage level problems and processing level problems, right? We have got a framework. We have got a framework like Hadoop for unlimited data storage and processing. I'll come back to this, right? I'll come back to this, but today I'll see, today if you see, this is your data. This is your data available in the current real world. This is the data. This is available in the current real world. So this from the year 1975 to 2025. Mm. If you take the last 10 years, 2015 to 2025, and the previous 40 years, the previous 40 years, the last 10 years, 2015 to 2025, the last 10 years, the previous 40 years, if you compare the data, right, the data generation, nearly 80% of the data what we are seeing in the current real world has been generated from the last 10 to 15 years. The previous 40 years, only 20% of the data has been generated. And that too, if you see, like GBs, TBs, or petabytes of data has been generated from the last 10 to 15 years. Previously, if you see, if you go back like 1990s or the earlier 2000s, you got to, how you used to carry the data. You got floppy disks like 1.44 MB. Later, you got compact disks in GB in MBs. Later, like DVDs. Later, you got USBs. Right. So day by day, the storage systems were increasing enormously. Now data has not reached terabytes, petabytes it has reached. Petabytes of data is getting generated. So for a huge data storage and processing, we need to have some proper storage systems. Reasons for this huge data generation, especially from the last 10 to 15 years, because of usage of technology, right? Because of usage of smartphones, because of usage of internet. Today, go back in 1990s, nobody knows about that internet. Now, everyone carrying internet, right? Smartphones, because of usage of technology, data has increased a lot. Previously, if we talk in the earlier stages, when the mobile phones were introduced in the early 2000s, to go back like 2001 or 2, see the internal storage was 128 MB or 256 MB. Now even 128 GB is a very small storage. In the coming years, it is going to reach terabytes and petabytes. So what are the main sources from where this data is getting generated? Mainly three sources of data. Mainly three sources of data. We say like social data. We say like social data, machine data, and transactional data. Social data, machine data, and transactional data. See, social data which has been generated from social websites, from Twitter, Facebook, all these things, right? Machine data means data which has been generated by reading, by scanning the RFID chips, barcodes, right? Go to a shopping mall for the items you purchase, a huge data is getting generated. Transactional data, day-to-day transactions. And if you talk about this, mainly three categories, three types of data. Three types of data. It's categorized into three types. Structured data. Structured data. Which is organized in the form of rows and columns, like database tables, Excel files. Now, semi-structured data which is not fully structured, which is not fully unstructured, like XML files, JSON files, and unstructured data, right? Like chart messages, articles, images, videos, all this comes as unstructured. But today the biggest challenge is how to handle this, how to handle and process, how to handle this unstructured data. Talk about the databases. Databases can handle what the databases can handle only structured data. They cannot handle unstructured or semi-structured data. But Hadoop can handle all varieties of data, structured, unstructured, and semi-structured. So as day by day, as data is increasing enormously, we need to have proper storage systems for storing and processing the data. We have got a framework like Hadoop for it. Hadoop performs both storage and processing. Hadoop is able to perform both storage and processing. For storage, does okay. So if we talk about any technology, right, it is either meant for storing or processing. If we talk about C, C++, Java, .NET, all this they are meant for processing. Talk about Oracle, MySQL, DB2, SQL Server, all this they are meant for storage. All this they are meant for storage. Either they are meant for storing or meant for processing. So, but Hadoop performs both storage and processing. Does Hadoop use any databases for storing its data? Means no. I said there are some drawbacks with the databases. Despite of the drawbacks, Hadoop doesn't go with any database for storing its data. Rather, it's going with a kind of file system called Hadoop distributed file system. There is a file system called Hadoop distributed file system. It doesn't use any database. And for processing, does Hadoop use any technology like Java or any other, right? No. It's going with an execution model like MapReduce, but currently it is going with Spark. So Hadoop is meant for storing and for processing. So if you take big data, huge data generation, if you take big data as a problem, you can say Hadoop is the solution. If you take big data as a concept, they can say Hadoop as the implementation. Yes. You may ask what are the drawbacks with the databases? Databases are widely used, and drawbacks with the databases as compared with Hadoop. Why databases can't be used for storing Hadoop's data?
Because Hadoop stores huge data.
Yes, unlimited data storage. So drawbacks with the yes, one by one drawbacks with the current databases. Current databases, right? Drawbacks with the current databases. First thing is limited storage. Limited storage, not unlimited storage, limited storage. Second is most of the databases, no parallel processing. No parallel processing is the most of the databases. And yes, any other drawbacks with the current databases means yes, if volume of the data is increasing, if volume increases, or if the data increases, speed decreases. I'm saying in databases, if the volume of the data is increasing, speed decreasing. For example, try to check with this query, right? Select I want total amount generated. So total amount from sales one has got 10 records. Total amount from sales one which has got 10 records, sales two which has got 10 lakh records. Total amount select the total amount total amount from sales 3 which has got a 10 crore records. So here if you observe, try to answer which query executes faster among these three. Which query executes
First one.
the first one, right? Because total amount of 10 records, total amount from 10 records as compared with 10 lakh or 10 crore records. The first query executes faster because of its less data, right? So query to query of data is increasing, speed is decreasing, right? Yes. And one more, if volume is increasing, if you take a labor example, a person or a boy, if it is carrying just 1 kg, he can run with that, right? He can run with that with the high speed. If that volume increased to 10 kgs, he cannot run, but he can walk with that. But if it is increased to 70 kgs, he cannot even walk. Means what is that? If that volume is increasing there, the speed is decreasing there for the person, right? In the same way here, if volume increasing, and if we take even if complexity increases, right, speed decreases. Yes, for example, even if we take a lever example, try to answer for this. What is 3 into 4?
12.
12, that's fine. 12 into 6,
72.
that's fine. 23 into 32, try to say.
It will take time.
524 into 732, 1083 into 9376. So here, complexity increasing, your speed is decreasing, right? If complexity increased, speed is in the same way. Here also, if I take a labor example, I take an example that is database point of view, if I take an example, I'll take the same query, total amount from sales one, right? Yes. Assume it has got 10 lakh records. Same table, but I'll go with different operation. Average amount from sales one. Again, same 10 lakh records. One more. Select this time standard deviation of amount. Yes, from sales one. Which query executes faster here? Which query? Sum of amount or average amount or standard deviation? Among these three queries, which query executes faster? First query, right? Obviously the first query, because average amount a two-step process. First sum has to be calculated, next average to be calculated. As compared with that first query, second query taking more time or not? This third query, standard deviation of amount, lot of internal processing is required, right? And if the major drawback with the databases, you see the fifth one, right? Databases can handle, or RDBMS can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured data. You see an example for this. You want to take reviews for a particular movie. If data is in a structured format in the form of rows and columns, for example, user is one column, review is one other column, right? User and the review, just observe. So in this way, user one, user two, user three, in this way 100 users. They are giving the review in the form of zeros and ones. If the movie is bad, saying 0. The movie is good, saying 1. If the movie is good, saying 1. If the movie is bad, saying zeros and ones, right? Therefore, they're saying in the form of zeros and ones. Can you write an SQL query to count the number of zeros and ones? To count the how many goods and how many not goods. Can you write an SQL query to count the number of ones and zeros? Aggregations, grouping and aggregations, right? Single grouping and single aggregation. Try to say, select review wise, count I want. From which table? Reviews, group by review. Select review wise count from reviews, group by review. Reviewers count from reviews, group by review. Output 1 and 0. Reviews means 1 and 0. How many in ones? Say that 90 you got. This 10 you got. 90 people saying the movie good, 10 people saying the movie is bad. So you can write this, you can handle this kind of data. But generally, reviews won't be given in the form of zeros and ones, right? Reviews won't be given in the forms of, yes. They give in their own text format. Movie is, for example, first person saying movie is good. Second person saying, okay, movie is not good. In the same way, in this, they're giving in their own text format. Can you write an SQL query now to count the number of goods and not goods? Can you write a, this kind of data you cannot handle, right? But still, if you're using this keyword count, okay, good you can count, right? But still it gives wrong computation because not good has got good in it. So it gives wrong computation, right? Yes. Review as count from reviews group by review. Yes. So these are the major drawbacks with this databases. No parallel processing, limited storage, volume increases, speed decreases, complexity increases, speed decreases, and databases can handle only structured data. They cannot handle unstructured or semi-structured, right? Yes, right. Which we can get many insights from this data. So combining Python and Spark will be the very efficient for the world of big data. That's why Apache Spark community came up with a tool called PySpark. Very high speed processing, I said. Very high speed processing. Okay. And if you see, I'll be discussing the features, main features. It takes time. But what are the real life use cases of this PySpark? Real life usage. In the commercial sector, it is used. The commercial sector, like for the banks and other financial systems, using Apache Spark today to retrieve the social customers, this customer social media profile, and also analyzing to gain the insights which helps in taking the right decisions, and also in credit risk assessments, and also in fraud detections with widely used in machine learning tasks. Spark has got a special library like Spark MLlib library, and also in the healthcare also it is used a lot. Healthcare also, right? Yes. To analyze the patient's records along with the previous medical reports to identify which patient is probably to face the health issues even after being discharged from the clinic. And even if we talk like entertainment industry, right? Yes. See, today, if we talk about the entertainment industry, it is moving towards this online streaming. The popular OTT platform like Netflix is using Apache Spark for this real-time processing for the personalized online movies or web series. Can process nearly 450 billion events per day that are streamed over server-side application. Trade and e-commerce. Right? So e-commerce websites like Flipkart, Amazon, all these they're using Apache Spark for this advertising. Right? Even other websites like Alibaba, right, providing offers and enhanced customer experience, optimizing the overall performance. Even in the tourism industry, even in the tourism industry, right? Yes, it's that is Spark used to provide advices to millions of travelers by comparing hundreds of tourism websites. So in this way, might usage was limited. So as part of this course, between Hadoop plus Spark with Python, we say like PySpark. So yes, knowledge of Linux, Python, right? Within this Python, you'll be getting this both the core and advanced Python. Nearly 50 sessions will be there on this. So for this Python, you are supposed to attend any of my Python batch. I do handle this Python course. Python, if you want to go with this, there's a Python batch, 8 a.m. in the morning. You can attend this 8 a.m. or 9 p.m. Evening, if you want to, you can go with 9 p.m. Morning means 8 a.m. But the timing of this will be at 7 a.m. Initially, it will be for 1 week, it will be at 8 a.m. We shifted to 8 a.m. But this 9 p.m. it will be at 8 p.m. Right? Yes. But this big data, Hadoop, PySpark, and Linux in this, you will have sessions on this weekends. So diagrams of this will be like 5 p.m. to 7 p.m. Right. So tomorrow also people can attend the session at same time at 4:30 to see more discussion on this. So before that, you can see that course content of it. So it goes for nearly 12 weekends, right? 12 weekends, around 3 months it takes. So and observe course content for this, starting with big data. What is big data? Needs, sources, challenges, RDBM, advantages of Hadoop, HDFS, Hadoop distributed file system. To know about this HDFS, configuring block size, name node, data node, HDFS architecture, metadata management, storage implications, fault tolerance, map reduce, phases of map reduce. Right? Yes, scoop, another important component for importing and exporting. Importing from database to Hadoop, exporting from database. During this operation, many other things can perform, right? Like filtering, main grouping, aggregations, right? Yarn, and how to write scoop jobs, and yarn, yet another associator, speculative execution, speculative jobs, speculative tasks, yarn architecture, yarn components, NoSQL databases. Advantage of this NoSQL, different types of SQL, and one NoSQL database like HBase will be discussed. Apache Hive in this Hive architecture, Hive meta. If we see lots, if you have got knowledge on the Hive component, only Hive component, you can just check Hive jobs. Lot of jobs for Hive. Just check this. 13,537 Hive job vacancies in February. Hive jobs if you got on Hive. So we'll be discussing in brief about this Hive Pastor, Hive query language, SQL, Hive local files to Hive tables, loading data from this HDFS to Hive tables, internal tables, external tables, XML data, JSON data, URL and weblog data. Yes, inserting into HDFS, UDAF, UDTF, partition tables, non-partition, multi-column partitioning, partitioning. PySpark, need for PySpark real life use case, PySpark session, PySpark context, repartitioning, broadcast variables, PySpark RTD computation, RTD actions, RTD computation, RTD persistence, memory only, memory underscore SCR only, disk only, PySpark core computing, different ways of creating RTDs, increasing the number of partitions, groupings and aggregations, single grouping, single aggregations, multi-grouping, multiple aggregations, process of group by key, reduce by key, various actions and transformations, count by key, count by value, zip function, group, PySpark, SQL data frame, Yes, creating data frame, empty data frame, and converting data frame to class, show structure type, class, class, select, collect, with column, rename, drop, duplicates, order by, sort, group by, UDF, flat map for each simple nulls, and PySpark SQL functions, ID functions, window functions, datetime, timestamp functions, JSON functions, PySpark built-in functions when EXP are split, can translate over different months between. So different functions. External sets, Spark and Hybrid integration, Spark and MySQL integration, what we see is action, narrow and wide transformations, addition of columns, handling, trying data back sources, creating a table from database, and local mode cluster applications, right? Stays and tasks, drivers and extents, deploying Spark applications to cluster points, tuning, integrate with PySpark streaming components, PySpark, and also Python, Python, why Python features, advantage, HT installation, flavors, Python operations, editors, IDs, data types, constants, variables, conversions, sequence, different operators, different keys, flow control, statements, looping statements, collections, Python tuples, dictionaries, functions, models, Python, package, there's an exception, pending, regulations, database connectivity, Python data and time, like advanced concepts like iterators, processors, and decorators, working with Excel, data analytics, introduction to data, pandas module, NumPy module, and matplotlib module. This is what will be discussed. Python in nearly 50 shades will be there for Python. And for this Hadoop, PySpark and Linux, toolkits it goes, right? So 15,000 is the course we fight for this big data, PySpark, Linux, and anyways, right? So tomorrow we can do the same. 4:30 p.m. You can click to see once, right? Fine. So it's introductory, like what is big data, Hadoop, what is PySpark, advantages, features, right? That's a briefing you about, right? So tomorrow we'll continue more discussion where we have stopped, right? Yes. Then I'm stopping for now, right? We'll continue tomorrow. Thank you for your time. Thank you.
Thank you so much for valuable.
Yeah,
It's a very brief introduction for us.
thank you. Yeah, good evening, Lord. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not?
Yeah, your screen is visible for me.
Yeah, fine. So in the yesterday we had a demo session, right? We had an introductory session. So what is big data? Why Hadoop and Spark? Drawback of this current databases, advantage of Hadoop and Spark, Hadoop scope and job market of Hadoop and PySpark. Right? So just I'll take 2 minutes what we have discussed right now. So today huge data is getting generated. Every application's generating it. Every application is generating huge data, right? Facebook, Twitter, Google, YouTube, email. So when currently we have got databases, but databases can handle up to some extent, but unlimited data storage is not possible, right? And drawbacks with the current databases. Drawbacks with the current databases. Before I go with this drawback with the current databases, right? So as data is increasing enormously, data is enormously, got a framework called Hadoop. Hadoop is meant for things. Hadoop is meant for two things: storage and for processing. It is meant for storage and is meant for processing. Storage, it does it is using a kind of system called output distributed file system HDFS for processing using an execution model called as MapReduce, and currently we are going with Spark. Storage HDFS for processing MapReduce on Spark. And for processing MapReduce or Spark. Okay. Hadoop is meant for batch applications. Hadoop is meant for batch processing or for batch applications. Hadoop is not for online applications. Hadoop is not for online applications. Hadoop is for batch applications. There are two types of applications. There are two types of applications. There are two types of applications. First one, online applications. Online applications. Second is what? Batch applications. Online applications and batch applications. Online applications, right? Online applications. User interactive applications. User interactive applications. Here user gives the input. Input. Example, booking a movie ticket. Making a online transaction. Batch application means here user non-interactive applications. See, here user is nowhere required. User non-interactive applications. Non-interactive. User non-interactive applications. Here user is nowhere required. Here user is nowhere required. User non-interactive application. Yes, user required. Example of this batch applications, right? Example of this batch applications. Railway ticketing PNR status. Currently, your status is 200 waiting state. After 1 hour, it became 150. Tomorrow morning, it is 100. Tomorrow evening, it got confirmed. Means it was in the waiting state. Automatically, it got confirmed. Your user is no way involved. User is no way required here. Is everything happening in the automated fashion? Okay. For example, credit card statements for millions of credit card data for millions of customers. Credit card statement for millions of customers. Statement generation. Credit card statement generation for millions of customers. Millions of customers. Similarly, phone bill statement generations for millions of customers. But yes, here. So batch applications where involve huge millions and trillions of records. For a single transaction, for a single online transaction, Hadoop is not required. For millions and trillions of records, we go for Hadoop. Now check this. Drops with a current database. Drops with 100 databases. limited storage, drawbacks with the current databases, limited storage, no parallel processing, as volume increasing, speed decreases. You see these queries, right? First query, second and third. First query executes faster as compared with the remaining queries, right? Query to query as volume increasing, speed decreasing, right? The first query executes faster because of 10 records, amount of 10 records as compared with total amount of 10 lakh records, total amount of 10 crore records. Increases. If complexity increases, speed decreases, right? If complexity increases, speed decreases. Total amount from sales one of 10 lakh records. Total amount from sales one of 10 lakh records. If you observe here, total amount, average amount, standard deviation of amount. Here, this first execute average amount is a two-step process. Next, standard deviation takes a lot of internal processing. And major drawback with the databases, it can handle only structured data. It cannot handle unstructured or semi-structured data. Before I go with ideas of Hadoop, you need to know something about the Hadoop architecture. Hadoop architecture. And I'll just take you out it, but it doesn't speak about the transaction processing architecture separately.